So let's get back on that section 5.2, and I want us to look at I don't know. Do y'all have a particular problem there that you want to see?
Twelve.
12. Okay, let's go with 12 then. 12 is the sine of the square root of x times the cosine of the square root of x. Is that right? Over what?
Square root of x.
Okay. Now, this is really one of my favorite problems, and you'll see why in a second. All right. Now, earlier, remember we had the problem sine square root, or cosine, it was cosine, yeah. Cosine square root of x over square root of x, and in that case, we just let u equal to the square root of x. And the reason we did that was because the derivative of cosine was not somewhere else in the problem. But now, if I let u equal to the cosine of the square root of x, well, guess what does show up in the problem? The derivative of cosine, or a form of course it's negative, but. So what I'm going to do here is I'm going to say let's let u equal to the cosine of the square root of x. So du is going to equal to the sine of the negative sine of the square root of x times 1 over 2 square roots of x dx. Again, the derivative of the square root, remember, you got to take the derivative of the outer portion times the derivative of the inner portion. Well, I could do this in one step, but I'm not. I'm going to let du equal negative 1/2 of the sine of the square root of x over the square root of x dx.
So those two are the same thing?
Well, I have the sine of the square root of x over the square root of x, right?
Yeah.
Dx. So that's going to become negative 2 du. So I've got negative 2 du. And again, that takes the place of this and this. So what am I left with?
Cosine square root of x.
And what do we know about the cosine square root of x? Well, not yet, not yet. There's something else we know about it.
The u value.
It's the u value, right? Cosine square root of x is u. So now, instead of having just a bunch of trig and square roots in there, now I'm just asked to take the antiderivative of u du. That's a lot easier to do. Now, the hard part's getting from this form to this form, but once you get to this form here, the anti-differentiation is a whole lot easier. Because what is the antiderivative of u? Yeah. And now the squareds cancel out, right? I mean, sorry, the twos cancel out. So I get negative u squared plus c. And that becomes, okay, u squared, u is the cosine of the square root of x. So it's negative cosine squared of the square root of x plus c. That's my final answer. But I want to show you the neat thing about this problem. Let's say I gave you that problem and you were like, which one should I let u equal to? And while we just worked this problem as saying, let's let u equal to the cosine of the square root of x, let's say now instead of that, I want to say, let's let u equal to the sine of the square root of x. So u equals to the sine of the square root of x, right? So what would du equal to? Would cosine of the square root of x times 1 over 2 square roots of x dx. It's actually positive here. It's positive because I'm not taking the antiderivative of sine, I'm taking the derivative of sine. Are you good with that? Okay. Any questions here? All right, well, again, just like what I had over here, only difference is I've got positive cosine instead of negative sine here, but I'm going to
Please pull them out each other.
I'm going to pull this 2 to the front here, so I'm going to have that 2 du is equal to the cosine of the square root of x over the square root of x dx. So now I've got 2 times, all right, sine of the square root of x is u, right? And then this cosine square root of x over the square root of x dx becomes that 2 du, right? So this is pretty much what I had right here, except I got a positive 2 instead of a negative 2. Are y'all still with me? All right, so this again becomes 2u squared over 2 plus c, which now becomes the sine squared of the square root of x plus c. So here I've worked the problem using 2 different u values. Here I let u equal to this. Here I let u equal to the cosine of the square root of x. And I got 2 different answers, right? So which one's right? Or did I get 2 different answers? No, you didn't get 2 different answers, even though they don't look the same. Let's go back to trigonometry real quick. You had a Pythagorean identity. And that Pythagorean identity was that if you had the sine squared of theta plus the cosine squared of theta, that was equal to what? 1. Are we still good? All right, well, sine squared theta is equal to 1 minus cosine squared theta, isn't it? So instead of having sine squared theta, I have 1 minus cosine squared theta. All right, but that's not the same thing, is it? I've got 1 minus cosine squared x plus c. And here I've got negative cosine squared root of x plus c. How could these 2 things be the same? Because c is a constant, right? So this c right here kind of eats up this 1 here. So it turns out that because c is a constant, that these 2 values really are the same thing. If y'all, do any of you have a dictionary in here?
I mean, I can look one up.
Okay, on your phone, look up ballin'. And if you look up ballin', you'll see this right here. You're not looking it up. It's almost like you doubt me. All right. Anyway, before it gets